Alright, so radical review. When you say radical in math, you are talking about square roots. There are lots of different ways to simplify this. One is to break it down into everything until they're all prime numbers. Another way is once you see a perfect square, you can stop. So let's take the square root of 150. Everyone found it now? Keep going until it says radical review. You will find it if you keep looking. Square root of 150. One of the easiest ways is to just start doing that. Remember that? Look familiar? Square root of 15 times the square root of 10. Questions on that? Okay, I don't know the square root of 15. I don't know the square root of 10, so I'm going to keep going. Break it down into 5. Yep, 5 and 3. That's right, either way. And then 5 and 2. None of those are perfect squares, but they're all prime, so I can stop. Now I have to figure out what goes inside the radical sign and what goes outside the radical sign. Ooh, I don't do this. So radical 5 times radical 5, they are like, they are friends, so they go out together in facts. The 3 doesn't find anything else like it. The 2 doesn't find anything else like it, so they're stuck under the radical sign, and they get multiplied together. 3 times 2 makes 6 inside the house. Okay, good. So we're going to do them separately, though. I want you to think about what happens with the x to the 4th, though, as well. So we'll do this 60. I'm going to do them separately, but you're right. 60 can break down into 6 and 10, and then the 6 can break down. Give you a second and try to break those down. 3 and 2, and then the 10 can be broken down. So the 6 could be 3 times 2, and the 10 could be 2 times 5. If you see a square root along the way, you can stop. But if not, keep going until everything's prime. So, if I want to simplify this, what goes outside and front? The 2's good. The 2's match, so they go outside without the house, without the radical. But what's stuck inside the radical? 15, 3 times 5. I know that 2 looks weird. Alright, so it's 2 times the square root of 15. But we're not done. We still have this. So I'm going to show you one way so that you can see it, and then I'm going to show you the way. So this breaks down into radical 4 times, sorry, where I'm getting 4 from, radical x times radical x times radical x times radical x. You don't have to write it out that way every time, but I want you to have it for the first time so you know exactly what's happening. What happens with these two right here? 1x, yep. What happens to these two right here? They turn into 1x, and everything's times. So what does x times x really mean? X squared, right? Okay, so what we have is 2 out in front. X times x makes x squared, that's out in front, and the 15 is stuck inside. Take 2 times x, and then times the square root of 15. All I did was blend these two together. Okay, the shortcut is, if you can remember this, when you have an exponent, if it's even, all you do is divide by 2. See how x to the 4th turned into x squared? That's when you take the square root of it. Don't write this down. For instance, the square root of x to the 10th would become x to the what? Good. Good. And don't write this down. The square root of x to the 16th would become x to the what? 8. Okay? So that's the shortcut rule if you remember it. Alright, number 3. Number 3, break down the 18. Let me write it this way. Square root of n to the 6. See how I just split it up? Square root of 18, square root of n to the 6. Well, let's do this one alone. Okay? So that makes square root of 9 and the square root of 2. You could keep going, but if you can see something, you can stop. What's the square root of 9? Just plain old 3. And square root of 2 is radical 2. Nothing happens now. Now we still have to go up and deal with the n. But it's the square root of the 6, and we just practiced that if it's an even number, it's really easy. That just turns into the third. If it's a square root, you just take the exponent and put it in half. So now we have to rewrite everything in the right order. 3 goes first, n to the third goes next, and the square root of 2 goes next. Number 4, there's 2 things to split it up into. Square root of 75 and a to the third. I'm going to leave a to the third alone for a second. Square root of 75, that could be 25 and 3. Write that down. Square root of 25 times 3.
I did 5 with 15.
Okay. You can keep going, and then at the end it should come up soon. You said 5 times 15? Okay, keep going with that and see if it matches at the end. Alright, but I can stop. I can take a shortcut here. Square root of 25 is just 5. Square root of 3 is just radical 3. Okay. But now we have to deal with this a to the third. It's different. You can't just divide it in half because it's not going to be a to the 1.5. So just help on some way. What did you think? That's right. Okay, what you do when there's an odd number is you take one of them away and you make it stay inside the house, and then you divide what's left over. Let me show it to you this way so you can visualize. A times A times A. There's 3 of them. A to the third. So these 2 will go out of the house, and that will just be A. But what happens to this one? It stays. That's right. So here's the shortcut. You can take 1 away and put it inside the house, and whatever's left over, you divide by 2. So we have to rewrite in the right order. What would go first? 5. It's not a squared though. Once you take it out of the house, it's just a. And what's left inside the house?
3 and 8.
5a rad 3a. It's a normal 5. But what happens with radical 3 times radical 3? Square root of 9. What is it not to be? 3. They go out of the house. Okay, everything's multiplied. The 5 has nothing to go with it. Radical 3 times radical 3 goes out of the house, becomes 3. And number 6, what's happening here is everything inside the parenthesis is squared. So it's 4 squared, and it's radical 5 squared. You don't have to write this out every time. Some things you can do in your head, but I'm going to write it for everyone to see. 4 squared and radical 5 squared, which really means radical 5 times itself. Radical 5 times radical 5. That's right. So 4 squared is 16. Radical 5 times itself just becomes, well, it's the square root of 25, right? And what does that become? Just 5. The square root and squaring are opposites of each other. You just get the number underneath. 16 times 5 becomes? Okay? So 2 square roots of the same number, cancel the square root out, and all you get is the number underneath. Questions there? Alright, number 7. This is where they look weird. But if you catch what I show you, these problems become really easy. Number 7. This is a true number here. It's just not written right. You're not supposed to leave a radical sign in the bottom. When we fix that, it's called rationalizing the denominator. So what I want to have happen is I want to have a 7 on the bottom. Look at that carefully and think, oh, what do you think? Good. You multiply by something that matches, so the number will stay the same, but the radical sign will go away. That's what you want to have happen. But whatever you do to the bottom, you have to do to the top. Alright, so you just look at the radical 7 and multiply by itself, and you'll just make the radical sign go away. Up top, the 3 is outside, and the 7 is inside. That's the answer because it can't reduce. That's right. You can't reduce the 7s because one's inside the radical and one's not. So keeping that in mind, look at number 8. What should I multiply find the bottom to make the radical sign go away to keep the 5. Radical 5. Good. Do that to the bottom, do that to the top. When you do that, you get 10. That's right. And on the bottom, what are you left with? Plain old 5. Good. That's your entire goal is to make the radical sign go away. If you can reduce, you should. So since 10 and 5 are both out of the radical sign, you reduce it, you get 2 over 1, and you end up with 2 radical 5.
Yes, wishes.
2 radical 5. Alright, you can't reduce the 5 and the radical 5 because they're both inside the house. I'm sorry, one is and one's not. Alright. Questions on that? Alright, this last thing you have to be able to do is to solve. You want n by itself. You want n by itself, so I have n times radical 2. I'm going to divide by radical 2 to make the radical 2 go away. But whatever I do on one side of the equal sign, I have to do to the other side, divide by radical 2. Alright, do I have to mess with this one? What do you notice already? Can you reduce? Yeah. This one can reduce with this one because they're both inside the radical house. So those can. That's the easiest kind that you have to n equals 2. That's right. Yep. If the radical sign matches the other radical sign, it doesn't always happen. Now I'm going to wait for everyone to stop again. Okay. Try it and then look here and check. Alright, n radical 3. You want n alone, so you divide by radical 3. You divide by whatever's attached there. On this side, you divide by radical 3 because whatever you did to the left side, you did to this side. But this time nothing cancels, right? So what do? I want to get rid of this. That's right. Multiply top and bottom by radical 3. Then okay, what do I get on the top? 15.